So, hey, welcome to, I guess, this week's installment of 2720 Small UAS Components. So, a couple things I want to cover. It might be kind of a quick view for those who are here and for those who are watching later. Let me switch over to my desktop view. Okay, and hopefully that's coming through. So it's really hard to believe that this is week 14 of a 15-week semester. So a week from tomorrow is the last official day of technically face-to-face classes. And since we're in this unique situation with remote delivery, we're going to have one more meeting next week. And then we got one more quiz for you guys, and then that will be it for 2720. And I'll talk about what's going on. Hopefully I'll have some more information on what's going on with the fall semester a little later next week. So for those who are wondering what we're gonna do. So anyway, on my desktop we are, like I said, week 14. So quiz 4 is open, and I think I've got it open until, I left it open all the way till Saturday night at 11:59 p.m. So you should have more than enough time to get it done. I realize some people are working now. They changed their hours and either got laid off from one place or found an opportunity in others to, that's why I left it open. So there shouldn't be any excuses for not being able to get the quiz done in a timely manner. So for all you procrastinators, you know who you are, is make sure that you get it done early. So this week, like I said, is finish up flight controls. And let me bring up, okay, so this week we're going to talk about part of command and control is transmitters. And it took me a while to find this, but this was an early British Army attempt at controlling an aircraft using a transmitter. So you can see that big box that they had was what they used. But first things first, hopefully everybody is doing well. So the good news for those who are still in Tennessee, that Governor Lee is not going to extend the stay-at-home order. After it expires on April 30th, which is 9 days away, so May 1st, hopefully things will slowly get back into whatever the new normal is going to be. So we'll have to wait and see, but that should take a lot of pressure off a lot of people. Hopefully they can get back to work, get the economy going again. And in the future, if you guys ever go to work for a company, and they have a 401k, which is for a retirement plan, is if they will match any amount of that. So some companies will match 2 or 3%, maybe even more. Always make sure that you get in, but it's tied to the stock market. So right now with the market being down, everybody's 401ks are down, but hopefully we'll get a fast recovery and you'll be able to take advantage of that. But start early. You guys will may think when you're first starting out you won't have the money, but get into a 401k when you get up in years. I use the word mature like I am. It's nice to have that. You can't count on Social Security. So announcements, not much going on. So quiz 4, like I said, it closes. It's open now. Closes on the 25th, which is Friday at 11:59 p.m. The other thing that's going on, besides fall and summer registration, I think we pretty much run the gamut on that. The pass-fail option, I'm sure you've gotten emails and heard about that, but that closes on April 29th, I think at 11:59 p.m. So you have to make your final decision by that time whether you'll accept a pass or a fail for a class versus a letter grade. Now remember, the pass-fail is good from a D- to a B+. If you elect to get a pass-fail grade and you get an A, that A counts. But remember in the future that pass will not count towards your GPA. If you're getting any type of loan or government assistance or grants or whatever, please check with One Stop to make sure that a pass option does not impact your grant money. So some of them will demand that you have a letter grade. So if you take a pass, you may have to pay part of that back. So once again, please check with One Stop before you make that selection. And from what I understand, uh, like I said, check more detail. If you've already made the selection and you want to go back and change it, is you can do that, I think, all the way up till the end of the day on April 29th. All right, so this week we're going to talk about transmitters, and I'm going to start off with something I know, I won't say know very little about, but engineers, programmers, they probably love this stuff. But transmitters operate on the 2.4 gigahertz band, and internally they can either use what we call PWM or PPM for their signals on that 2.4 gigahertz band. And the PWM stands for pulse width modulation. Okay, and PPM is pulse position modulation. And I always remember what PWM, but I never remember what PPM stands for. And you can come up here and look at this middle right here, but you can see the difference between a PWM and a PPM signal is that pulse width. The value that that pulse puts out is based on the width of that actual pulse. So you can see that different widths mean different things. So when I'm making an input on my transmitter and I'm moving the gimbals or the sticks around and it's sending a signal, is when I make those inputs, it translates it into these pulses and then sends it to the receiver, and then the receiver will translate that. As opposed to a PWM, notice that it's where that pulse is in relation to a period of time. So that sends the value from the transmitter. Now, the other difference on a PWM, and you're going to see this when we do our first builds in the box quad, is we're going to start off on a PWM signal. And what that means is when it's going to send out this PWM signal, the receiver is going to pick it up. And the receiver, let's say we're going to have 4 channels, one for pitch, roll, yaw, and throttle, is there'll be 4 separate cables coming off of that receiver into the controller. So in other words, it's like an analog signal. So when I make an input on the throttle, which is channel 3, then the signal wires for the throttle, that signal goes from the receiver down that wire into the autopilot, into that flight control module on channel 3. So if I've got 10 channels and I need all 10, then I need 10 separate wires coming from there. As opposed to the PWM, these pulses continue, they always cycle through. So we can get a number, I won't say it's unlimited number, of different channels through one set of wires. So it's a digital signal versus that analog signal. So sometimes you'll find transmitters that can do PWM, okay, or PPM, but they can only do one of the other. Sometimes you'll find them where they can do both. And I'll show you one of our transmitters that actually can handle this. So part of the programming that we have to do is to make sure we define whether we're going to do a PWM signal or a PPM signal. I mentioned it last week. So on transmitters, there are different modes that you can get. Once again, some transmitters, and like some of the ones that we use, we can actually configure these internally to be either mode 1, 2, 3, or 4. There are some transmitters that when you buy, you have to designate whether you want a mode 1 or a mode 2. So typically in the United States, we have mode 2 transmitters. That's just, you don't have to use that, but that's typically what you'll find. So if you look on a mode 2 transmitter, is one of your sticks is forward and backwards is throttle. So we push to increase and pull back to decrease. If we go to the left, basically the aircraft will turn to the left, or if it's a multi-rotor, it will yaw to the left and vice versa to the right. On the right-hand stick, if I'm working on a fixed-wing aircraft, if I push forward, that means the elevator goes down, which brings the tail up, which drops the nose down. So the aircraft pitches forward. If I pull back, then the elevator pitches up, which forces the tail down, which forces the nose, and the aircraft will climb. Okay, if I want to bank to the left, I take the right stick and move it to the right, or excuse me, to the left, to bank left. And, you know, if I want to go right to that. Now, if I'm using a multi-rotor in there, when I push forward, it will actually make the aircraft go forward. And if I pull back, and it will make the aircraft come back to me, go backwards. So that's mode 2. If you look at a mode 1, which typically you'll find in Europe, so once, you know, a little bit different, throttle, instead of being on the left stick, is on the right stick. Aileron is still where it typically is, rudder still where it typically is, but elevator is on the left. So a little bit different in controls. And then you can take a look and see the difference between mode 3 and mode 4 for that. So some transmitters will have the ability to program this. So if they're pretty much digital, it can do it. Some of the older ones, you either get a mode 1 or a mode 2. And so you got to be very careful when you're purchasing those. So I'm not going to go everything on how a transmitter is set up. You know, on the top of this one, there's an antenna. A lot of the newer transmitters, what they've done is they've buried the antenna wires within the molded frame of of that frame for the transmitter there. So it really doesn't make a whole lot of difference. But the only whole lot of difference is when you'll hear when they talk about antenna diversity. So typically what you want is the antenna on your transmitter is to be in the same plane as your receiver. So in this case where I have the antenna on top, typically I want the antenna on my aircraft to be either up or down, but sticking in that Z-axis there, so we don't have that diversity, diversity for that. Talking about the sticks, so once again, typically we fly mode 2. So on that left side there, you can see that the stick will move in different directions. Is forward and backwards is throttle increase, so throttle decrease is down, and then rudder is left and right, and or yaw for a multi-rotor, and then the right side controls our ailerons and elevators. Okay, most transmitters have an on-off switch. Now, very important, and we always turn on, regardless of what system we're using, we always turn on our transmitter first. Okay, so we always turn on the transmitter, and then we'll turn on the aircraft next. The reason for this, if I turned on the aircraft and it picked up a spurious signal from whatever, now remember I said that transmitters are on 2.4 gigahertz. Well, so is Wi-Fi. So, it may pick up some signal from your telephone or you name it, it can do it. So this makes sure that when the aircraft powers up, that the transmitter is already on, and we're going to have control of it. So the other thing you'll see on some various switches, it could be rotary knobs. So you have the ability to program these, which you'll see later on. So when we get into some of the other ones with autopilots, we can program switches to go into a GPS mode, into an ADI mode, or even a fail-safe mode. That as I move the switch, it will make commands, through the transmitter to the receiver, and then the autopilot will act accordingly. So it's really hard to talk about transmitters without really having one in your hands and being able to turn these things on and show you everything that we're doing. The ones that you guys will be using most is we use these Turnigy i6Ss. They've been around for a while. Before the tariffs with China, You could pick one of these up for about $50. And with that $50, you got the transmitter, and you look, and it also came with 2 receivers. Um, if you look in the upper right-hand corner there, it says it's got a 6-channel PWM, okay, for pulse width modulation. So it can do up to 6 channels. If you look at the transmitters, see they've got 2 antennas there. It's that black one with the green labeling there, with the label. But down there on the very end of it is, since it's 6 channels, there are 6 outputs. So if I was to use the full 6-channel capability, I would have that receiver mounted, and then I would have to have 6 cables that came out of that transmitter, either to my servos for an airplane, or if I'm using a multi-rotor, into my autopilot system. Now, we also have the ability, like I said, is to change this over to also use PPM. And sometimes you'll hear it referred to as S-bus, which is I assume a serial bus. The difference with this and the receiver is that blue one with the yellow tag on it. And there's only 4 pins, so 1 set of wires that come off that go in there. So all 10 channels in PPM go through 1 wire. And that's where that difference in that pulse position modulation makes a difference. So it's continuously cycling through when I make inputs. It changes where that pulse is, and it knows that I am commanding this. So depending on what system you're using, sometimes it's great to have a PPM, and sometimes you'll need a PWM receiver. Now, the thing is, you cannot interchange these, okay? So in other words, if I have this set up, so a lot of times students will hook this up and not, they'll leave it on PWM for a PPM or vice versa, and this will not work. So you got to go in to the transmitter to reset things up. A little bit different on this transmitter. Notice there's no external antenna. So it's got the antenna, and actually there's 2 of them embedded within the plastic. So, not much difference. It's cleaner. Almost has a DJI feel to it. We still have the 2 gimbals. So the 2 sticks there. I have a variety of switches up on the top that we can program all those switches. So let's say that I had a multi-rotor that I built that I had retractable landing gear. So I choose which switch I want, and I'll just say, in this case, the far right one up there, which is a 2-position switch that when the switch is up, the gear goes up. When the switch comes down, the gear comes down. So we can program that, sends a signal from the switch through the transmitter to the appropriate receiver. The other thing different about this one is you'll notice it has a screen. So we have an LED screen in there that we can cycle through. We have quite a few menus where we can turn things on, turn things off. We can make some adjustments that you'll get a chance to do that a little bit later on when we program some like the box quad. We have to make some adjustments that we will make in the transmitter, and we can use that screen to do it. Now, the other difference on this one, you notice it's got 2 power buttons, all right? So on the other one I showed you previously, on this one, it only has 1 power button in the middle that we can go ahead and turn that, turn that on or off. This one has 2, and it's kind of like a fail-safe. So in order to turn this transmitter on, you have to press and hold both of those power buttons at the same time. And the same thing to depower. So if I inadvertently hit one without the other one, it's not going to turn off. So it's very hard to accidentally turn this transmitter off. The other transmitter that you'll see later on when you get checked out on the Phantom 4 Pros is the DJI. Notice once again, it's got the 2 sticks to it. It's got a power button on the left. On the right button, that silver button you see is actually a return to home feature. So in an emergency, you can press that button and the aircraft will come back um, in a straight line, and it will go up to a pre-programmed altitude and come back. The little lights on the bottom, well, they're not lit up now, but that's the battery indicator. Uh, so those 4 lights on the right are the battery indicator, and then the status light of whether you're connected or not is actually on the left. So the other difference on this one, we've got a few more switches on top and on back that you really can't see that are programmable. The difference for this is, so we've got this transmitter which operates on 2.4 gigahertz. So that's how we actually command the aircraft. But then it also has video capability. So one of those antennas is for on 2.4 gigahertz, the other one's on 5.8 for the video. In this case, you know, the DJI Phantom has a sensor on it, and it can actually bring back that sensor. We use iPads on them, and you take the iPad through the lightning connector, hook it up into the USB for the transmitter, and not only will you get video, but you also get telemetry. So you can see the status of the aircraft battery, you can see heading, altitude, airspeed, proximity sensors. So there's a whole different amount of things that we, you know, that information that we can get as operators by using, you know, a viewing device. So I just wanted to show you the difference of the ones we're going to start off early that we don't have a monitor to, and then ones that we do. So there's a lot more information coming to you. So anyway, like I said, kind of short today. Transmitters is one of those things that you kind of need to get a hold of and play with and program. And coming up in 3710, which is, or actually 3711. So we've got some of you guys have signed up for it. You'll get a chance to start off building the box quad, and you're going to use the Turnigy i6S with a PWM receiver and program it, and that's where we're going to learn to fly manually. So I'm going to go ahead and stop my screen share for that. And if anybody has any questions this week, make sure that you contact me. And you know, don't wait till the last minute, because we've only got, after tomorrow, just a week left. So hope everybody's doing well, and I'm going to stop the recording and open it up for any questions.